All right, guys, here's a little bit of a tricky problem. This is a solving rational equations problem, all right? And if we look at the denominators of each of these, they all look kind of similar. So let's see if we can factor out parts of those and see what we have left over. In this one, we can take out a 3, giving us a plus 1. Over here, we can take out a 4, giving us a minus 1. And in this one, we can take out a 2, which leaves us with a plus 1. All right, so if I look at each of these parts, I have a couple of a plus 1s, I have an a minus 1, and I have a 3, a 4, and a 2. Okay, so it gets a little bit tricky, right? Now, you might want to multiply all those together. 3 times 4, which is 12, 12 times 2, which is 24. But if you just look at this side, 3 times 4 is 12. Okay, we can also say that we can do 2 times 6 to get to that 12. So it's actually 12 that's going to be the number in front as our common denominator. So I'm going to maybe put over here L, least common denominator is going to be 12, and then we need one of the a plus 1s and one of the a minus 1s. Okay? Which means that if that's my common denominator, on the top I need to multiply by what I don't have with that. So what I mean is, here if I go like 12 divided by 3 is 4, so I need to multiply this times 4. And also a plus 1 doesn't have the a minus 1. This needs the 4 and then the a minus 1. Likewise, this one has a 4, so to get to 12 I need a 3. 3 times 4 is 12. And it has an a minus 1, so I need the a plus 1. Okay, this one over here has 2, so to get from 2 to 12 I need to multiply this times 6. And it has the a plus 1, so I need the a minus 1. Okay, I know all my denominators are going to be the same, so I can just go ahead and cancel those, right? And then just work with the numerators, the tops of these. So on the top of this one here, we have 7a times 4 is 28a. And then we still need the a minus 1. Minus 5 times 3 is 15. And then a plus 1. Then over here, 3a times 6 is 18, so it equals, right, equals 18a times a minus 1. All right, so now we just need to distribute and then solve for a. So if we do it here, it's going to give us 28a squared minus 28a. On this one, I have to distribute the negative 15 to both. So negative 15a minus 15. On this one equals 18a squared minus 18a. Okay, let's see if we can put some of these things together. First off, if I move my 18a squared over by subtracting it, that leaves me with 10a squared. And then I have negative 28a minus 15a minus 18a. So let's see, what if I move the 18 over by adding it? That'd be, if I add 18 to 15, that's positive 3, and then negative 28 plus 3 is negative 25a. So we use all the a's, and then I just have the negative 15. Okay, and then I think both of those things cancel, so it equals 0. These are all multiples of 5, so we can take a 5 out, or divide both sides by 5. That leaves me with 2a squared minus 5a. 25 divided by 5 is 5a. Negative 15 divided by 5 is negative 3, equals 0. Two numbers multiply to give me negative 6, and add to give me negative 5. Or, let's see, what would that be? Negative 6 and 1. So I have 2a squared minus 6a plus a plus 1a minus 3 equals 0. Group these together. We can take out a 2a. So that's a minus 3. Over here we already have a minus 3, so I'm just going to take out a 1. So we have 2a plus 1 equals 0, and a minus 3 0. Okay, this is gonna leave me with a equals, subtract the a, or subtract the 1, divide by 2, that's negative 1/2. And on this one, a equals 3. Okay, but we do have to put it back into our originals and check, all right? So what we're looking for is 0 in the denominator. And let's see, does that happen anywhere? 3 times negative 1/2 plus 3, nope, that's fine. Over here, 4, that's good. And 2a, let's see, that would be negative 1 plus 2, nope, that's fine. So a equals 1/2 is good. What about 3? 3 times 3 is 9, 9 plus 3 is 12, that's good. 12 minus 4 is 8, that's good. And 6 plus 2 is also 8, so this is also good. So both of those answers work. A equals negative 1/2 and a equals 3.